Hi everyone, welcome back to the last part of Pre-Calculus 5.2 verifying trigonometric identities. Today we're going to focus on the second learning outcome or learning objective, determine whether equations are identities. Alright, let's look at our first exercise. Test whether each equation is an identity by graphing. If it appears to be an identity, verify it. If not, find a value for which both sides are defined but not equal. Now in this type of questions, we're going to use the graphing calculator, but since most of us don't have a graphing calculator, we're going to use an online tool to do that. We're going to graph the left side alone and the right side alone. Okay, if those two graphs are the same, then we can conclude that this is an identity. If they're not the same, just by looking at the graphs, then that verifies that these two are, this is not an identity. In that case, we want to find a value for which both sides are not equal. So let's try to graph those functions first. So the left side, y equals 10x plus 1 over 10x minus 1. And this is the graph as we see. Okay. Now the right side, y equals 1 plus cotan x over 1 minus cotan x. Alright, now it appears that both graphs are the same, but don't be fooled by that. Let's make sure we look at the big picture. Okay, now the second graph appears. Okay, so one of them is purple, the other is green. Okay, as we see by these two colors. Now that tells us that both graphs are not the same, which means that this is not an identity. Okay, now we need to find the value of x. Okay, for which both sides are defined but not equal. Okay, now to do that, we need to look at the graph. Any value where the graphs are not intersecting, that would be the value that we're looking for. Alright, now since the graph is not that clear, let's just pick a value. I think for most of the values the graph will be the right side and the left side would be different for most values of x, but let's just pick a value for x. So now let's check a value for x. Let's say x equals 0. For the left side, tan 0 plus 1 over tan 0 minus 1. Tan 0 is 0, so it's 1 over minus 1 equals minus 1. For the right side, 1 plus cotan 0 over 1 minus cotan 0. Now cotan 0 is undefined. Okay, so the left side is minus 1, the right side is undefined. That proves that this is not an identity. Okay, let's look at another example. Alright, this time we're looking at number 39. Cosine square x minus sine square x equals cotangent x minus tangent x over tangent x plus cotangent x. Again, let's graph both sides. Okay. So for the first one, y equals cosine square x minus sine square x. Okay. And the right side, y equals cotangent x minus tangent x over tangent x plus cotangent x. Now, it seems like we only have one graph, no matter how many times we enlarge it or shrink it. There's only one graph, which says that this is an identity. Okay, so this is an identity because we only have one graph. It's time now to verify the identity just like we did before. Alright, let's look at the right side first. Try to convert everything to sine and cosine. So what we have is cosine x over sine x minus sine x over cosine x over sine x over cosine x plus cosine x over sine x equals, common denominator here is sine x cosine x, cosine square x minus sine square x over, same common denominator, cosine x sine x sine square x plus cosine square x. This goes out with this, so we're left with cosine square x minus sine square x over sine square x plus cosine square x. Now right here this is 1, so this is cosine square x minus sine square x divided by 1, which leaves us with this. Okay, so again, to do these kind of problems we have to use a graphing calculator. If we don't have graphing calculator, we use an online tool to graph the right and left side of the equation. If the graphs coincide, that means it's an identity. Then we have to prove that using the old methods that we've used before. And then if the graphs do not coincide, then we have to find just one value of x where the right side and the left side are not the same. Hope that helps. Now let's look at another example. Secant square x minus 2 secant x tangent x plus tangent square x equals 1 minus cosine x over 1 plus cosine x. Let's graph both sides of the equation. So for the first one, y equals secant square x minus 2 secant x tangent x plus tangent square x. That's the left side, and the right side, y 1 minus cosine x over 1 plus cosine x. Well, as we can see, these graphs do not coincide, which says that we don't have an identity. Alright, so let's pick a value for which the two graphs do not intersect. The easiest value would be 0. For the first graph, you know, the value when x is 0, this graph will be 1, and for the other one, when x is 0, the graph will be 0. But let's verify that. Okay, so secant square 0 minus 2 secant 0 tangent 0 plus tangent square 0. Secant 0 is 1 minus 2 times 1 times tangent 0 is 0 plus 0 square. This is 0, 0, so it's 1. That's the left side. The right side, cosine 0 is 1, so it's 1 minus 1 over 1 plus 1 equals 0 over 2 equals 0. So the left side was 1, the right side was 0, and that proves that this is not an identity. Okay, so we did that. We verified that by graphing and then by selecting a value for which both sides are not the same. Okay, I hope that does it for you. Go over the examples that we did. That will help you with doing the homework assigned to you. And for now, stay safe and have a good day. Please do not forget to subscribe and leave some comments on the channel. Bye.